Hello everyone, myself Professor Soma, lecturer in Mechanical Engineering Department from Madhyadada Mane Polytechnic, Pelate, Solapur. Now, today we are going to see study of the subject that is the elements of machine design. In machine design, that is the unit 1 fundamentals of design. Student should know the basic knowledge of applied mechanics and strength of material. Then after you'll easily understand design of machine elements. That is the machine design. You see the syllabus of machine design in semester 5th Mechanical Engineering Department. You see that is the point 1, philosophy of machine design, definitions, different design considerations, types of loads, concept of stresses, pressures, different types, factor of safety, stress concentration, designation, concept of creep, fatigue, endurance limit, maximum and minimum shear stress theory, aesthetic and ergonomics considerations. So, student, what is mean by machine design? Machine design is the process of selection of the material, shape, size and arrangement of mechanical element so that the resultant machine will perform the prescribed tasks. Basically, you know what is mean by machine. Machine is a combination of linkages having definite motion and capable of performing useful work. In philosophy of machine design comprises of three major parts, that is the input, process, output. Input means consisting number of principles, then process, it includes operational discipline with result in action, then finally a critical feedback instrument which measures the advantages, reveals the shortcoming and illuminates the direction of improvement. Also, the philosophy of machine design based upon the general principles derived for engineering design that are need, physical reliability, economic viability, design criteria, design process, reduction in uncertainty, future design decisions, communications. Then the next slide you'll see the different phases of design. That is, it includes aim, that is the objective, synthesis, analysis of forces, material selection, design of element, modification, detailed drawing, and that is the finally production. So, in this, the design process starts with identification of need and decision to do something about it. After a number of iterations, the process ends with the presentation of the plans for satisfying the need. Depending upon the design task, several phases may be repeated before the finalization of design. So you see these types of points is explained the figure, that is the complete design procedure which shows phases of design and iterations. Then the next slide indicates that is the general design considerations. So what is mean by design considerations? While designing any component, the strength and stiffness are very important factors that are considered in machine design. But there are a number of other considerations that the designer has to keep in mind while designing any product. Some of the important factors considered in design are, you see the step by step design considerations, that is the type of load and stresses, motion of parts, selection of material, shape and size of the parts, frictional resistance and lubrication, convenient and economic feature, use of standard parts, safety of operation, workshop facilities, number of machines to be manufactured, cost of construction, assembling. So, what is the type of load? Means in this the various types of load will be acts on the machine component, because due to this internal stresses are set up so that that types of loads are steady load, fluctuating load, repeated load, etc. So what is the motion of parts? Means successful operation of any machine depends on the arrangement of the parts which transmit required motion. Then after, you see the selection of material. The designer must have the knowledge of properties of material and their flexibility, means durability, electrical conductivity, strength. Means these are the mechanical properties of metals. The next, shape and size of the parts, frictional resistance and lubrication, convenient and economic feature, use of standard parts. In this, the use of standard part is closely related to cost, because the cost of standard or stock parts is only a fraction of the cost. Similar parts has to made by order. In this way, you should consider these points while designing any component. Then we will discuss mechanical properties of materials. You know, strength, fatigue, elasticity, plasticity, stiffness, ductility, malleability, hardness, resilience, toughness, creep. We should discuss about these properties one by one. So, what is meant by strength? Before we have to study actual properties, that is mechanical properties of metals. The mechanical properties of the metals are those which are related with the behavior of the material to resist mechanical forces and load. These properties help for designing machine component in various types of size and shape to fulfill the conditions as per design. So what is meant by strength? Strength, that is the static strength. It is the ability to resist stress without failure under static loading. The ability of a material to stand up to forces being applied without it bending, breaking, shattering, or deforming in any way. Then next, elasticity. What is meant by elasticity? You know, it is the ability to regain original shape and size after load removal. It is the ability of a body to resist a distorting influence or stress to return to its original size and shape when the stress is removed. Then what is meant by plasticity? You see the animation. It is also ability of a material to undergo irreversible or permanent deformations without breaking or rupturing. Then next is the ductility. So what is meant by ductility? The animations are clearly tell about property of material, that is the ductility. It is often characterized by the ability of material to get stretched into a wire by pulling or drawing, it is elongated. Then next, malleability. Malleability, it is the ability of the material to be flattened into thin sheets under applications of heavy compressive forces without cracking by hot or cold working. It is the property of a material which enables it to undergo change in size and shape without rupture under the application of external load. It's called as malleability. The next, brittleness. Brittleness, it is the ability to rupture with negligible deformation. Means it is the brittleness of a material indicates that how easily it gets fractured when it is subjected to a force or load. Then toughness. So what is mean by toughness? Obviously it is a capacity to absorb energy without fracture. The animation shows it is a characteristic of a material that does not break or shatter when receiving a blow or under a sudden shock. Then hardness. So what is mean by hardness? Resistance to penetration, abrasion or plastic deformation. It is the ability of a material to resist scratching, wear and tear and indentation. So next is the stiffness. Ability of an object to resist deformation in response to an applied force. Then next, what is mean by fatigue? Fatigue is the weakening of material caused by the repeated loading of the material when a material is subjected to cyclic loading. It means when a machine component is subjected to repeated stresses, it fails at stresses below the yield point stresses. Okay. The next, what is mean by creep? Creep, it is the property, means it is the progressive deformation under load at high temperature. It is the property of a material which indicates the tendency of material to move slowly and deform permanently under the influence of external mechanical stress. So what is mean by resilience? Obviously it is a capacity to absorb energy when deformed within elastic range. Means it is the ability of material to absorb the energy when it is deformed elastically by applying stress and release the energy when stress is removed. You see the resilience. Then one of the most important factor, that is the types of loads. The mechanical component are subjected to various types of external load that may be acting because of energy, torque or power transmission. Their self-weight, frictional resistance, inertia or centrifugal forces or due to temperature gradient. These static or dynamic load causes bending moment, torsion moment in the component. The loads are basically classified into the four types of categories, that is the steady load, fluctuating or variable load, suddenly applied, that is the shock load or impact load. So what is mean by steady load? It is the type of load which do not changes its intensity and direction of applied load. Fluctuating means, as you know, it is said to be lie or variable load. Obviously it changes continuously. So suddenly applied load, that is the shock load. It is the type of load which suddenly applied and rapidly builds up stress in the component. For example, this type of load means shock load, leaf spring of vehicle, as you know. So what is mean by impact load? The instantaneous arrest of a falling of mass or shock load meeting two mating parts. Means, for example, blows of hammer, impact of punching machine operation. Okay, so what is mean by stress? As you know, stress obviously when an external force applied on a body or component. Some of the internal forces are set up in the body which resist the external force is known as stress. Strain. So what stress? Obviously it is the ratio of force upon area. So strain, it is the change upon original. Means whenever a force is acted on a body or component, it undergoes deformation per unit length. The slide you will see the types of different types of stresses. Means tensile stress, compressive stress, bending stress, shear stress, direct. In that obviously includes single and double shear, torsional shear stress, bearing pressure, that is the bearing pressure or bearing stress, crushing stress. As you know, these all types of stresses you are already studied in the subject of strength of material. So types of stresses means what is mean by tensile stress? When a mechanical component is subjected to equal and opposite axial force called as the axial tensile force. Okay, so then the stress induced in it, it is called as tensile stress. Obviously you know compressive stress. When a mechanical component or element is subjected to two equal and opposite axial, that is the push in nature, then the stress induced in it is called compressive stress. Okay, so you should know about these types of stresses. So now further we will discuss in during next lecture after some of the subjects, that is the machine design, the beats. Okay, thank you.